This is just a small explanation about the tooling I made for the collet on the prop boss. As you can see, it's all together now, and it is turning the engine over. Just thought I could make it sound a bit more like an engine. Still not a lot of compression, but we can spin the engine over with the prop boss. Right, the tooling I made and the bits I made that failed was, as I explained before, I got the dimensions of the prop boss wrong and thereby made the collet too small. The making of the tool, the first tool that worked, because I got the dimensions wrong, I made it out of 10mm bar, thinking I'm having a change in diameter from the 7mm at one end and the 3mm change in diameter I get as I go up the it's a pity that I'm brain dead. Up the taper. I go up the taper 10mm, the diameter is increased from 7mm to 10mm. So I made the first cutter using a piece of 10mm bar, and it worked. And of course it was too small, couldn't do the job for me. So having reworked my calculations, I've made it out of 12mm, and we're starting at 8mm and finishing at 11. And the reason this didn't work the first time was very simple. I wish I could get a tighter shot of this. The flutes, when I cut them in exactly the same way on the milling machine as I'd done the first tool that worked. As we saw in the video, after cutting the flutes on this one, it didn't work, and the reason was because the increased diameter, the flats on the top of the cutters was greater. So there was about 3 or 4mm of flat at the back of the cutting blade, which there wasn't on the original cutter because of the diameter. So that's why I had to go back to the mill and machine out the back of the blade, so it just leaves a 1mm wide blade, and after a little bit of stoning on it, it cut like a trooper. So that's the reason why it wouldn't cut first of all. And as I said in the video, as you start to cut with these, obviously you're only introducing a small amount of the tool in, it cuts well, and as you gradually increase your depth, the more of the flutes come in contact with the metal, with the aluminium, and of course it's more difficult to cut. But that one is still cutting, and it cuts even by hand, so it can't be too bad. I get some chippings off just rotating it by hand, so it's still cutting. So that's just a bit of mild steel cut and some aluminium. So that's the reason why the second cutter didn't work. Right, moving on, the next job is going to be, I think, setting the mill up to do the pattern of 4 holes on the back cover and the crankcase and the front cover and the front of the crankcase, so we can start to bolt it together. The ball bearing crank is running quite freely, there's no slop in it, it feels nice. So I think I better press on and do the calculations. What I'm going to do is on my I'm using Fusion 360. I'm going to draw this back plate out, and I'm going to have my starting point, the datum of the center of this, so I can set this up in the vise, locate the center. I can put a stop on the vise so I can repeat it, and then I can machine the 4 holes, which are 2.5mm, and then hopefully, although I'm just looking at it now, obviously I can do the front cover because I can locate that in the same way. So one setup will do 2 items, and I was just looking at the crankcase now. I know by measurement my crankcase is 12/100ths under 25mm, which was my target, and both bosses on the back plate and the crank retainer are 30/100ths over. So when I position this back in the same jig, I'm going to have a problem. I can work from the back, the fixed jaw of the vise, and because it will, yeah, I'm working from the fixed jaw of the vise, that's alright. Cylinder will be out. Cylinder will be out, and the movable jaw we can pull back to here, and my stop can go on the side of the case there. So that's it. We'll be able to machine all 3 objects, components, from one position in the vise, which is nice. I have already machined the top, so we can do that, drill them, tap them, and then we can bolt the back plate and the crank to the crankcase, and that'll be another step closer. When I fit this into the vise, because it is 40/100ths different to the back cap, I will have to allow 20/100ths on the DRO to move it to the centre just a little bit closer to the fixture of the vise. As long as I do that, and I might have to allow 20 hundredths on the side as well. As long as I make them allowances, I still should be hitting the centre of that, and the 4 holes will then match the 4 holes in there, and the job will be a good one. I've finished rambling now, I've had enough. Diet's going well, lost a pound. I'll lose more than that doing the bloody lottery. Anyway, there we go. Another little episode taken from a different angle. Whether this is going to be good or bad, I can't tell you. But anyway, I'll go back in the house, fire up Fusion 360 and see if we can get some G-code to drill those, because the mill, when it's running CNC, is very accurate, especially, well, on everything, cutting, sizing, positioning holes. It's mustard, and once you've got the G-code written, it is a lot quicker than trying to mark it out and pop it and center punch it and piddle about. So between the two strategies of manual machining and CNC, we're getting the jobs done. And I think proof of the CNC accuracy was this cylinder and the cutting of these oblong orifices, and the, what do they call these? Oh, my head's gone again. It's terrible, this. Transfer ports. Cutting of the transfer ports, and the little holes at the top of the transfer ports were all laid out and machined on my CNC machine, and they all came on the money. There's the exhaust, which is another oblong, and using the same setting as I'm going to do now, in other words using the same fixture, I was able to put the cylinder in, and as you can see, well, you can see, it is absolutely on the money. So I'll end there and I'll go and do it and shut up. So if somebody would like to like one of these or dislike my videos or comment, all will be greatly received. Thank you for watching, and bye for now.